We are going to talk about analytics, big data, and audit automation. Actually, this is an introductory discussion of the potential role of audit analytics in the emerging world of big data. I would like you to pick up this URL and put it on a browser and watch this particular 60 minutes clip. It actually has two MIT Harvard experts on automation and basically corporate IT discussing the role of robots in the future world. And I think it's a refreshing view of major patterns that are happening in the world, which I think will have some substantive effect in audit automation. The slide actually shows a book by Ian Iris that actually discusses the many things and the many features of data analysis. It's pretty good reading, and you should have a look at it. This book actually not only looks at data analysis, but looks at its usage in business. These two books are really generic books on the area of business utilization of data, and try to give an insight to future utilization of data. John Brennan's book looks more specifically at the future analytics, but I think it's reasonably conservative in its views. Let's just talk a little bit about audit automation. Within the framework, I assume that you already had looked at the 60 minutes tape. You would understand that in the recent years, in many different industries, work has been outsourced and or directed towards areas of lesser labor costs. And so therefore many companies have created factories, have made strategic alliances with businesses in India, in China, in Latin America, even in Ireland. And these alliances basically were pretty much set to just decrease labor costs. By decreasing labor costs, they obviously increase some other costs. Obviously, there were, in order to send materials and to capture materials in other countries, you have transportation costs, you have transfer technology costs, you have kind of the natural cross-boundaries costs of doing business, processing in business, and et cetera, et cetera. So most of the times when you go to a different place to take advantage of labor, you kind of change a little bit the nature of your expenditures. What that clip of 60 minutes actually points out is that there is an emerging trend of bringing some of this work back to the United States. Now, this is not totally unambiguous and totally clear that this is actually going to happen, because you could also use this robotics and these labor replacement actually in the outsourced location, like in India and China, and decrease labor costs over there. Now, the labor cost equation is interesting, because these machines are not cheap, and so their amortization has to be less than the cost of labor costs being replaced. Furthermore, the maintenance of complex robotics or the complex machines in lesser developed nations is more problematic, particularly because manufacturers are not there and the support is not there, and there are other factors like restrictions of exports and et cetera, et cetera. The social complexity of this work of this transfer of work is substantive. However, I think it's reasonable to say that there is a pattern of remanufacturing in the United States, and not only manufacture, but in other things that you can automate some of the work. Some of the work has been coming back, or at least have not been exported. Now, translating or transferring this kind of line of thinking into auditing is a little bit looking ahead. We in the accounting world and the audit work have been very, very slow on adopting technology, and we have been pretty slow at following the needs of business. Actually, there is kind of major delay in first, technology gets developed. Second, technology gets impounded in tools. Third, these tools are used in business eventually. And once they are used in business, there is a substantial delay for these tools being impounded in the accounting world or the audit world. And that's really, the audit world has been very, very slow. And when the large efficiencies of business utilization technology start being realized, and often you cannot really perform assurance work without really using the similar technologies or better technologies that business is using, is that the moment that they, kicking and screaming, the audit world is pulled into the technological world. A major impeachment, major difficulty on the usage of technology in auditing has been the fact that rules are antiquated, audit rules are antiquated, and auditors within a fixed budget on an engagement are forced to perform technologies that are totally antiquated. My usual example, my usual discussion is, say, that auditors are trying to shoot down a tank with bow and arrow. What does that mean? Bow and arrows were developed many decades ago, many centuries ago, and they are not appropriate tools to deal with more recent technologies like tanks or automatic weapons. But the rules were developed when the bow arrows were existent. A trivial example, but it has a point. So bringing technology back, or placing technology in the audit process, faces this major obstacle that is the existing rules of auditing. Recently, the PCAOB has been rather strict with several of the big firms. There were very stringent findings in, for example, in the quality of the audit of Deloitte. And Deloitte was told to do more sampling, which is not exactly what we think, how we think about modern auditing. Actually, that's just a motivation for us to start talking about audit automation and talk a little bit more about big data in audit. We'll come back to discuss this a little bit later. So today, looking at the slides, large firms are sending much work to India. And each one of the firms first surrounds this outsourcing of work with reasonable sequencing for competitive reasons, and also for some concern about what regulators will say about that. And the third thing is for some serious concern that the clients will think that you're cheapening the work or not supervising properly the work. Now, the work that they're sending out is not the high-end analytic work, but typically is low-end, labor-intensive. And of course, it has to be performable off client sides, or you can send it to a third-party location. Don't confuse sending work to be performed outsourced in other countries with auditing affiliates of companies in other countries. This is a different thing. This work that is outsourced also tends to be repetitive and tedious in nature, and this saves substantive money to the firms, or at least some money to the works. However, this is actually bad because you are basically separating the examination of data and the low-level manipulation from more substantive analysis. And so the analysts get data that is already prepared, and they don't get a chance to look deeply into data. Anyone that does research knows that touching the data a little bit and manipulating the data a little bit gives you additional view of the data. So this separation of raw manipulation of data and analytical functions raises some issues, and which will have to be dealt with automation. Now, it's really reasonable to expect that some of these manual functions that are being sent to India or to China or to South America, or even performed in the United States in outsourced mode. One of the large firms actually has outsourcing location in Florida and one in Bangalore in India. These functions are so manual and so repetitive that actually they can be progressively automated. And typically automated functions are even cheaper than manual repetitive function processed in less costly labor environments. Now the second thing, which is probably less known or less thought about, is this idea that we also can impound into software analytic interpretation. And people would say, well, this is judgment, and judgment cannot be automated. That's absolutely not true. Progressively over the years, many judgment calls or many judgment factors were actually formalized into decision software. And while we in accounting and in auditing have been pretty primitive on this thing, if you look at paper pulp mills, or you look at iron smelting plants, and etc., much of its development, production, and etc. is substantially automated and continuously monitored and continuously adjusted. And those type of technologies eventually can come into number processing and automation processing. I listed here Bill Gale's book, Artificial Intelligence Statistics. This is where Bill Gale was a scientist at Bell Laboratories, and he developed a thing which he called the REX system, REX standing for the regression expert. And the REX system actually emulated what expert would do getting regression data. And the way Bill did it, he basically developed a regression framework. Regressions were run, executed, and then he emulated knowledge, or the method that an expert would develop to analyze the data. Although this has been done nearly 20 years ago, it hasn't been impounded automatically. It hasn't been impounded in business processes. But this is the famous, what we call the hype curve, that technology gets developed or gets talked about, and then takes time before business adopts it. Takes time first, and this time partially is an evolution of technology itself, meaning better software, better hardware, faster hardware comes in to perform the functions. The other part of it is that even when it's better and is feasible, it takes some time for business to recognize it, accept it, and impound it. And the social technical systems are very slow to implement systems. However, what we know is that the cycle of bringing new technology into business processes has been accelerating substantially, like the development of technology has accelerated substantially. I want to start talking about big data. And the reason I'm talking about big data is because this is prevalent in modern environments. And you need to kind of pause here and think for a little while about what's happening to the audit environment. The first thing is that we audit typically financial statements. And financial data is the tail after the dog, mean, events happen, events are planned for, things are developed, plans are complied, facilities are generated, and at the end of that, there is a sale. Bill McCarthy says, by the time that the first bookkeeping or entry is made, most of the interesting things on the business process have already happened. So the financial data is reasonably small, and it's just kind of after the event, so to speak. In reality, however, businesses need substantive amount of data in order to perform things that they do. And I now say that the usage of data in corporations is bimodal, or is in two modes. One mode is what we give to the world, which is the external reporting type of things. And the external reporting type of thing is small data, usually very highly manipulated within the rules that allow substantial changes in data. So large companies typically will pick up financial statements of their divisions, will consolidate them, and perform all kinds of magics with that particular data. Now, so that's assuming within the rules of financial reporting. That's one part of the world. The other part of the world is most large corporations live and die by the ERPs. And in these ERPs, they have not only financial data, but have production data, manufacturing data, human resources data, that goes on and on and on, as that are planners, facilitators, enablers of business. And this data is really the data that on a day-to-day basis supports business. Now, you should confront and think about this of the past. Originally, balance sheets and income statements were really developed to help managers run their businesses. And many of the compromises, like FIFO, LIFO, depreciation, etc., were a product of information processing limitation. What does it mean? You wouldn't be able to constantly be verifying the value of an inventory piece that you have sitting in your warehouses. You wouldn't be able to count them constantly. You wouldn't be able to understand where they are. You wouldn't be able to understand what stage a sale is, and et cetera, because at that time any of these activities required a person to get up from the table and go verify something. Very inefficient, very expensive. So you really don't want to have a business measurement accounting function that costs more than the actual production and the execution of the business. Now that has dramatically changed. Most of these things are reasonably automatable, and the cost, or instead of being the dollars and the tens or hundreds of dollars, is in the cents or in below the cents, done automatically, non-traceable, in large level of detail that wasn't possible before. Furthermore, in addition to the business in the ERPs, not only covering the financial area, but covering many other areas, what you have is that ERPs are starting to actually have very close to the event real-time data, because they are able to sense transactions and book them as soon as they happen, whether there is a piece of material being moved, or there is an electronic e-commerce transaction being generated, or a manufacturing piece completed by a machine. These things are measured automatically, and they're recorded automatically, they are summarized automatically, and they might be linked to the internet for competitive pricing, or for competitive valuing over a wide range of potential activities. So this is a whole different world where you have data being collected very rapidly. Most self-respecting ERPs will basically know the closing value of bank balances. Very often they will know it at any moment. Then they typically will know the value of your payables, the value of your receivables, and if they do manufacturing, just-in-time inventory levels. These are just necessary things to conduct modern business, and they are real-time things. If you confirm this with external reporting that we present, external reporting is quarterly or yearly, is full of approximations, and is full of things that really don't mean very much. Now, modern business, in addition to having this endogenous level of data, which is what the business is doing internally and that we are measuring in one direction or the other, it also has some environmental things that large systems or large corporate systems need to understand. They need to understand competitive prices. They need to understand macroeconomic data. They have a large set of external data that progressively is being formalized as part of the internal business trading or the business usage data. Furthermore, there is this whole kind of internet type of data, like blogs and logs and Facebooks and et cetera, that provide very valuable marketing information. And ex-post analysis is useful, but more useful is to detect as real time as you can patterns on this data. Now, if you start thinking about arm click movements and you start thinking about posts on internet in all over the world and et cetera, you start really collecting large amounts of data which have a major price in recency. And so companies are starting to collect data in what we call big data, but big data today is pretty small data to what is going to be 5 years from now or 10 years from now. There have been analysts that predict like tenfold expansion every 5 years and sometimes every 2 years on data. So even the concept of big data is a concept that you have to kind of open your imagination to think what it is. Now, the fact that data is expanding so dramatically have changed a little bit the focus of what do you do with data and how do you analyze data and et cetera. Most of us went to school and many of us took statistics. And what we actually typically do in statistics is data descriptions and then some kind of hypothesis basis analysis. So basically you have an idea of something that is an effect, and then you test hypothesize and confirm or not confirm a particular hypothesis. And that's obviously a product of the restrictions on tooling and the restrictions on data availability and actually processing costs of manual basis of data. Now, another way to approach data is to beat up data and try to understand what's in there. People talk about data mining. In general, a good way to call it is exploratory data analysis. Actually, the acronym EDA is an acronym that tends to be used. Scientist at Bell Laboratories, John Tukey, a great statistician, has explored this area easily 40 years ago, published a book, and since then, for a while has been forgotten, and very recently with the area of data mining and etc., EDA raises its big head, and EDA is a very, very important area of statistics. And here I show you John Tukey's book published in 1977, and just kind of as an interesting sidebar here, one of the things that Tukey did and some of his followers like John Chambers and et cetera, they actually developed ways of showing data. And they were this particular cover of his book shows types of displays that you are at this moment you have started seeing it with Excel and with other tools. But in reality, he developed a whole set of ways to show in data, and he used to prepare these displays manually. So they're very, very laborious ways of displaying it, and it kind of explains why EDA didn't take off very much, because, you know, exploring large receptacles of data manually is nearly not possible. But at this moment, the whole world has changed, and there is tremendous popularity of basically visualization, exploratory algorithms, and trying to use exploratory data to create hypotheses about data and understand relationships that you didn't imagine they existed before. We are going to rely on the next few slides about some work on McKinsey and Out of the Economists. It's not just about big data. For the big players in enterprise technology, it's about finding big patterns beyond the data itself. And it's this kind of your ability to extricate yourself from the details and try to understand what are the main effects. As I said before, the explosion of online life and cheap computer hardware has made it possible to store immense amounts of unstructured information, like emails, internet clickstreams, and then search the stored information for strengths that can be exploited. So text mining, unstructured data information now is really what most people start thinking to do. Fields like legal field, now there is extensive usage of what they call e-discovery. And e-discovery is basically going to records of different type, which you used to do manually before, which is a very, very different power of the particular tool. And the next thing about this is the cost of this particular exploration of large data. Companies doing this at large scale look for similarities between one field and the other, hoping for some commonality. Some businesses decided that this is the way they're going to make money. In the last 5 years, IBM has spent some $14 billion in purchasing analytic companies in the server's big data initiative. As they explain, we look for adjacencies between one business and another, said Mr. Mills, who is from IBM, and this is from The Economist. The trend for looking for commonalities, overlapping interests, is emerging in many parts of both academia and business. At the ultra-small nanoscale examination of cell, researchers say the disciplines of biology, chemistry, and physics begin to collapse into each other. There are commonalities in analysis, and there are commonalities among the fields. In this course and in the course before, you started learning a little bit of R. In a broader sense, search for patterns, students of the statistical computer like knows R have used methods of counting algae blooms to prove patterns of genocide against native people in Central America. Online marketers look at your behavior in a number of contests to sell you something you may not even know you wanted. While it is attractive to contemplate the way everything may become connected to everything else, it presents a number of large challenges. The lab research model has been important for over a century in both scientific advancement and product development. Soon, it may also have to accommodate a search for truth based only on pattern spotting. Again, exploratory data analysis allows you to spot patterns, and then you can experiment, or you can look at your data with models and see if that particular pattern exists. In the nearer term, companies will have to make tough choices about where to invest and which signals to watch. Trying to do everything will still amount to doing nothing. You have to focus down what you're going to do. McKinsey points out that radical customization, constant experimentation, and novel business model will be the new hallmarks of compensation as companies capture and analyze huge volumes of data. Just as an example out of the economist, a top market executive at a sizable U.S. retailer recently found herself perplexed by the sales report she was getting. A major competitor was steadily gaining market share across a range of profitable segments. Despite a counterpunch that combined online promotion merchandise, her company kept losing ground. When the executive convened a group of senior leaders to dig into the competitors' practices, they found that the challenge ran deeper than they had imagined. The competitor had made massive investment in its ability to collect, integrate, and analyze data from each store, and every sale unit had used this ability to run a myriad of real-world experiments. At the same time, it had linked this information to suppliers' database, making it possible to adjust prices in real time, to reorder hot-selling items automatically, and to shift items from store to store easily. By constantly testing, bundling, synthesizing, understand that, constantly testing, bundling, synthesizing, and making information instantly available across the organization, from the store floor to CFO's office, the rival company became a different, far nimbler type of business. Now, McKinsey has these questions about big data. What happens in a world of radical transparency with data widely available, meaning you and your competitors have access to similar data. And so it's become some of the exogenous data, not endogenous data, is quite transparent. If you could test all your decisions, how would you change the way you compete? And testing your decisions, you could position yourself in the internet with 2, 3, 4 different facades, different lines of business, and see which one works together. Actually, there are startups that actually do that for you. They try different approaches for your web performance. How would your business change if you use big data for widespread real-time customization? How can big data augment or even replace management? Could you create a new business model based on data? So these are the questions McKinsey asks. And McKinsey has this set of quadrants that examine big data in relation to the different industries. And you can see here in the vertical axis, big data, ease of capture, difficult to capture, to high, to very easy to capture, and big data, value potential. And you can see the areas like information, finance, and insurance are the ones that are easy to get data and have high value. Administrative service, construction, etc. are more in the low side.